Good morning, my students of grade 10. Today we are going to study about the lesson force. Once again let's start it with the definition. What do you mean by force? Force, you all know where force is defined as. Let's go through some points. First of all, know that force is an external agent. If something makes me work, then that something is an external agent. Yes, that is force. So force is always an external agent. Okay, and which changes. Okay, which changes or tends to change what the state of object from rest to motion or motion to rest, and then after position, okay, then speed, the better say velocity of moving object. Okay, force is defined as an external agent which changes or tends to change state of object from rest to motion or motion to rest. Okay, similarly position and velocity of moving object. Okay, by using these points you can define force. And according to Newton's second law of motion, we have derived, yes, in grade 9, according to Newton's second law of motion, F is equals to m into a, and where m stands for mass and a stands for acceleration. Okay, force equals to mass into acceleration, and its SI unit, as you all know, SI unit of force is Newton. It is indicated by N, and it is a vector quantity. Vector quantity means it has both magnitude and velocity. Okay, this was the basic concept about force that you have studied in previous classes as well. Okay, in grade 10 we are going to talk about specific type of force, that is gravitation. Now in universe, okay, in the universe nowadays, if an object has certain mass, okay, if an object has certain mass, then it tends to attract another object having mass. Yes, it always tends to attract another object towards its center. Okay, if an object has certain mass, it always tends to attract another object toward its center. Okay, and definitely that another object also is going to have mass, isn't it? That another object also has mass. That means that another object also tries to attract this toward its center. Okay, the basic rule is any object having mass attract another object toward its center. Okay, this is the basic rule of the universe. Okay, in universe, any object that have mass, they tend to attract another object toward its center. Now let's say this is A and this is B, and here you can see A has certain mass, means A attracts B toward its center. Okay, A attracts B towards its center with some force of attraction. At the same time, B also has mass, so B also tends to attract A toward its center. So as a result, they just move toward each other's center, and finally they simply collide. Okay, or in many cases in universe we can see they simply collide to form single bigger mass. Okay, most of the planets are said to be formed in this way according to dust cloud hypothesis. You will study that in later lessons. Okay, so this is the basic rule of universe. Now the force of attraction, that force of attraction which by which the objects having mass attract each other toward attract each other toward their center, it is called gravitation. Okay, this phenomenon or process is called gravitation, and the force involved is called force of gravitation. Okay, so we can go to definition. Gravitation is defined as the force of attraction between any two bodies having mass that attract each other to their center. Okay, this is it. Gravitation is defined as the force of attraction between any two bodies having mass that attract each other to their center. And that force of attraction, the force of attraction between two bodies having mass that pull each other to their center is called force of gravitation. See, some prefer to say that gravitation and force of gravitation are same thing, but I prefer to say they are not the same thing. Okay, gravitation is a process, whereas force of gravitation is the force involved in that process. Okay, it is like this is pulling, the process of pulling, and this is a force by which we pull. Okay, that's why the definitions are somehow similar to each other, but the only difference is sorry, it's not force. Okay, process. Okay, gravitation is defined as the process of attraction between any two bodies having mass that attract each other to their center, and the force of attraction between two bodies having mass that pull each other to their center is called force of gravitation. Okay, the only different word here is process and force, otherwise they are same. But once again, keep this in mind, gravitation is the process and the force of gravitation is force and applied in it. Okay, now let's discuss about Newton's universal law of gravitation. Okay, Newton's universal law of gravitation was proposed by Sir Isaac Newton. Sir Isaac Newton in well, I'm not quite sure about the date, but Sir Isaac Newton proposed the universal law of gravitation, and according to the law, let's go to the basic first. There are two objects, yes, object A and object B. There are two objects, object A and object B. Both objects have certain mass, and mass of object A be m1 and mass of object B be m2. Okay, it has certain mass m1, it also has certain mass m2. Then we know that object A is attracting, okay, this is the distance between center of two objects. Object A is attracting object B toward its center, yes, that, let's say it is force Fa. Okay, object A is attracting object B toward its center by certain force, okay, that be Fa. Okay, similarly object B is also attracting object A toward its center, okay, by applying some force, that be FB. There are two forces attracting. So two forces on the action here. Okay, one force applied by object A that attracts B towards its center, and another force is being applied by object B that attracts object A toward its center. Okay, there are two kinds of forces acting. Okay. Now, gravitational force, as we discussed earlier, gravitational force is the composition. Okay, don't copy this. Okay, force is equivalent to composite force of Fa and Fb. Okay, gravitational force is the composite force of Fa and Fb, which can be, since they are applied in such a way that okay, they can be multiplied. Now, what factors affect their force, amount of their force? Okay, first of all, we all know that force is directly proportional to mass. Okay, that means if an object has more mass, then it can exert more force. Once again, don't write this part. Okay, I'll tell you when to write. If an object has more mass, then it exert more force, and if an object has less mass, then it exert less force. Okay, now Fa, it should be proportional to m1, whereas Fb should be proportional to m2. Okay, hence Fa depends on mass of A and Fe depends on mass of B. Okay, now if gravitational force is composite of these two forces F and Fb, then we can say F is proportional to m1 into m2, because the overall force of gravitation is affected by mass of both object A and B. You got it or not? See once again, gravitational force, or F, yes, we are indicating it as F. Gravitational force is composite force of Fa and Fb, and since Fa is proportional to m1 and Fb is proportional to m2, then the composite force F must be proportional to product of m1 and m2. Okay, this is one of the condition. Okay, now another factor, let's go to another factor. Force of attraction is inversely proportional to distance between them. Okay, force of attraction is inversely proportional to distance between them. Think about a magnet. Yes, there is a magnet, isn't it? And if you keep a nail very far from it, would you feel much force, or will you feel more force when the nail is kept held near the magnet? In which case will you feel more amount of magnetic force, force of attraction? In case it is at certain distance, or in case it is closer to the magnet, in which case will it experience more force? Definitely the answer is when it is near the magnet. So it shows that force of attraction is inversely proportional to distance. Okay, if distance increases, less amount of force of experience. If distance decreases, more amount of force is experienced. Now let me tell you again, force is actually inverse. Force has inverse relation to squared function. Okay, that means the force, gravitational force between A and B, as I said, it is the composite force of Fa and Fb. Then the force between A and B is inversely proportional to distance, but it should be squared. Okay, because Fa is also affected by distance and Fb is also affected by distance. Their mutual force is being affected by distance. That's why we should write F is proportional to 1 upon d square. Okay, let's say this is Fad and Fb is proportional to 1 upon db, but since d and db they are same, let's not write this. So we can simply say F is also proportional to 1 upon d, Fb is also proportional to 1 upon d, and since gravitational force is the composite force of F and Fe, we can say F is proportional to 1 upon d square. Okay, this should be our second equation. Okay? Don't copy this. Once again I'm saying don't copy this. This is just for concept. Okay, you do not prove it in this way. We should not prove it in this way. Okay, don't copy this. This is just for concept. So you got it. Force is proportional to product of mass of both object, and force is inversely proportional to square of distance between their center. Okay, this is the key. Now do not copy up to here. Okay, this you do not need to copy. This is just for understanding the concept of Newton's universal law. Now let's go to Newton's universal law. According to Newton's universal law, Newton's universal law of gravitation suggests that force of every body in the universe having mass attract each other with a force of attraction which is called force of gravitation, and it is, see, up to here we have already discussed, yes, every body in the universe having mass, they attract each other with a force of attraction which is called force of gravitation, that we have discussed in here while defining gravitation. Yes, okay, so that forms the first part of the statement. Now that force of gravitation is I'm coming through here. Yes, F is proportional to m1 into m2. I'm writing this is directly proportional to the product of masses of both bodies. And okay, see, I have stated this one. I have used this point to state it. It is directly proportional to product of masses of both bodies and inversely proportional to what I'm going to state this one now, square of distance between two bodies. Okay, this is the statement. Actually it seems very long, yes, but actually it is not very difficult to memorize. Okay, just break it into three parts from here to here. Okay, let me write it red. From here to here, up to this much, it is one statement which we have used to describe to define gravitation. Okay, every body in the universe having mass attract each other with a force of attraction which is called force of gravitation. Okay, then from here to here, second statement. Okay, it depends on this. Yes, it is directly proportional to the product of masses of both bodies. And then third statement is here. Okay, according to this one, it is inversely proportional to the square of distance between two bodies. Okay, so it won't be difficult to memorize, although it seems very long, but it is not difficult to memorize. Now let us consider two bodies having mass m1 and m2 separated by distance d. Okay, that means this is object A and this is object B, its mass is m1, its mass is m2, and the distance between their center is d. Okay? In that case, then F be the force of gravitation. Up here it is not so much new concept. Yes. Now according to the Newton's law of gravitation. Okay, first was there F is proportional to m1 into m2, isn't it? This is equation number 1. And second is F is proportional to 1 upon d square. This is equation number 2. Now combining both equation, we get F is proportional to m1 into m2 by d square. Okay, combining this equation, we get F is proportional to m1 into m2 by d square. And in physics, you know this very well. By removing the proportionality sign, we can add a constant. Okay, so it becomes F equals to capital G m1 into m2 by d square. And here, where G, this G is a constant term. Okay, and that constant term is called universal gravitational constant. Okay, its experimental value, and G is equal to its experimental value is 6.67 into 10 to the power minus 11, and its SI unit is nm square slash kg square. Okay, now how did I find this SI unit of G? Okay, how to find it? If you ever get confused of it, okay, in while suddenly you have to tell what is SI unit of G, then maybe you might not remember this. Okay, that happens much frequently, especially to me. Okay, that means it might happen to some of you as well. In that case, how to find out SI unit of G? I use a trick. See, we start from here, F equals to G m1 into m2 by d square. But since we need to find out SI unit of G, what I do? I isolate it. For that, I can cross multiply all other terms. So d square comes to numerator, m1 and m2 comes to denominator. Once G is isolated, then we can say as unit of G is equals to, what is unit of force? Newton. Unit of d square? Meter square. And unit of mass is kg into unit of mass kg. So it gives us Newton meter square slash kg square. This is how you can find out SI unit of G, or SI unit of universal gravitational constant. Do you understand or not? Now let's go through it once again. Let us consider two bodies having mass m1 and m2 separated by distance d. Then this is a figure. Object A has mass m1 and object B has mass m2. They are separated by distance d. Then the force of gravitation between these two objects be F. Now, according to Newton's law of gravitation, F is proportional to m1 into m2, first statement, and second statement was that F is proportional to 1 upon d square. Yes, by combining these two equations, we get F is proportional to m1 into m2 by d square. Now, by removing proportionality sign, you can add a constant that gives us F equals to G m1 into m2 by d square, where G is a constant called universal gravitational constant, and its calculated value is 6.67 into 10 power minus 11, and its unit is nm square slash kg square. How did I get this unit? It is quite easy to find out SI unit of G. Let's start from F equals to G m1 into m2 by d square. Isolate G equals F into d square by m1 into m2. Now taking unit of all terms, I get nm square slash kg square. Okay, next let's discuss how to define universal gravitational constant. That means G. Now, once again, we'll start from the equation F equals to G m1 into m2 by d square. This equation is given by Newton's universal law. Now, if you are to perform an experiment in laboratory, you can not manipulate the value of F. Okay, you cannot manipulate this variable, but you can easily manipulate these three variables. Isn't it? Mass of two objects and distance between them. So if we take mass of both objects to be 1 kg, okay, if we take two objects having 1 kg mass each and separate them by a distance of 1 meter, that you can do. Yes, 1 kg of mass, okay, 1 kg of mass separated by 1 meter of distance. This you can manipulate. In that case, then we get F is equals to G into m1. It's 1 kg. m2 is also 1 kg, and d square means 1 meter square. By multiplying all of this, you get F equals to G. See, F equals to G. Okay, when mass is taken, mass of both objects are taken as 1 kg and distance between them is considered 1 meter, then in that case F is equals to G. What does it suggest? That a universal gravitational constant is actually the force of gravitation, amount of force of gravitation. Okay, universal gravitational constant is actually the amount of force of gravitation. In what case? When mass of two objects are 1 kg and set distance between them is 1 meter. Okay, in this specific condition, when you take masses of two objects as 1 kg and they are separated by 1 meter, what amount of force of gravity exists between them? What amount of force of attraction exists between them? That force of attraction is actually G. See, it is quite easy. Yes. Now, therefore, universal gravitational constant is the amount of force of attraction, or better say gravitation. Okay, force of gravitation, in which case specifically between two objects having 1 kg mass each and separated by 1 meter distance. Okay, this much is the definition of universal gravitational constant. Now, next we need to do is the numerical problems related to Newton's universal law of gravitation. Okay, let me copy a question. Okay, numerical question number 1. Okay, let's go to question. I've copied it. What is the force of attraction between a child of mass 40 kg and a teacher of mass 80 kg if the distance between them is 2 meters? It is quite easy. See, there is a child of 40 kg mass and the teacher of 80 kg mass, and distance between them is 2 meters. Now, what amount of force of attraction is between them two? And don't be confused, this force of attraction means physical force of attraction. It's not like the attraction in love or affection or any such emotional things. Okay, there we are not in emotional class, we are in physical class. Okay, now solution. First of all, let's write given informations. Mass of child, that means m1 is 40 kg, and mass of teacher m2 is equals to 80 kg, and then distance between them that means d is equals to 2 meter, and we all know this value is constant. Okay, and we always needed in every question, universal gravitational constant. So better you never forget the value of g, 6.67 into 10 to the power minus 11 nm square slash kg square. Okay, having written this much, now by using, okay, I'm going to write it, okay, force of attraction, F equals to what? I'm going to use next page. Okay, now by using Newton's universal law, we have F is equals to capital G m1 m2 by d square, capital G 6.67 into 10 to the power minus 11, m1 40, m2 80, and d square is 2 square. Now we have to solve this index, yes, isn't it? This index can make the things complicated. So what I prefer to do is I simply separate it out, okay, in a separate cluster like this. Okay, I have separated index there and the numbers here. Now let's do this much of math. 4 10 the 40, that means 6.67 into 800. This can be cancelled, so it gives a 6.67 into 8, 8 7 are 56, carry 5, 8 6 are 48, 48 and 5 53, 8 6 are 48, 53. Okay, 53.36 into 10 to the power minus 11. See, this is already in scientific notation system, but in scientific notation system this number should be below 10. It should be between 1 and 10, but 53.36 is definitely not between 1 and 10. It is more than 10. That means decimal should be here. Okay, and how can you take it there? That means you need to shift the decimal by one digit, isn't it? 5.336. If the decimal has been shifted by one digit, then what we do in index, we do plus 1. Okay, if we have to shift decimal in forward direction, then we need to do plus in index. If you have to shift decimal in backward direction, then you need to do minus in index. Okay, so in this case the decimal has been shifted in forward direction by one digit. Okay, that's why in index we have to do plus 1. Therefore your final answer would be 5.336 into 10 to the power minus 10 Newton. Sorry. Okay, I think I'm missing something here. I have already cancelled the decimal. Yes, I don't need to take this decimal, means there is no decimal here. Okay, there is no decimal here. Okay, I'm going to correct it from here once again. I'm sorry for the error. By multiplying this, all we get 5336 into 10 to the power minus 11. Now you see, this is definite, as I told you, the scientific system must be between 1 and 10. This is definitely not between 1 and 10, and to be it between 1 and 10, decimal should be here. Right now decimal is here, so it should be 5.336. now see, the decimal has been shifted by 1 2 3. It has been shifted by 3 digit, means in index you have to do plus 3. Okay, if decimal is shifted in forward direction, then you have to do plus, and by how many digit? By 3 digit, so plus 3. That's its final answer should be 5.336 into 10 to the power minus 9 7 8 8 9 10 11. Okay, Newton. This is your final answer. Okay, now I'll give you another question, but that one you have to do. I'll give you a question and its answer. You please try it. And once again, we always, if you see some indical terms like that, what you do, separate those indical terms in a separate cluster, different cluster, and then try to solve it. Okay, again, it's again one. I'll do one more question. Let me copy the question. Okay, here's the question. The mass of Jupiter is 1.9 into 10 to the power 27 kilogram, and that of the Sun is 1.99 into 10 to the power 30 kilogram. Calculate the gravitational force between them if they are separated by 7.8 into 10 to the power 8 kilometer. It says there is a Sun and there is Jupiter. Okay, its mass is given, and its mass is given. It is how much? 1.9 into 10 to the power 27 kg, and it is 1.99. Sorry, this is 30. Okay, 9 into 10 to the power 27 kg, that is of Jupiter. And between Sun and Jupiter, the distance between them is 7.8 into 10 to the power 8 kilometer. This much information are given. So given information you have to write down. Mass of Jupiter is equals to 1.9 into 10 to the power 27 kg, and mass of Sun m2 is equals to 1.99 into 10 to the power 30 kg, and distance between them d is equals to 7.8 into 10 to the power 8 kilometer. Okay, once again the thing is here, see the distance is given in kilometer, yes, but kilometer is not an SI unit. It is not an SI unit. Okay, but as I told you, all units of all terms must be in the same system to do numerical. And kilogram is in SI system, then kilometer, this the unit of distance must also be in SI system. How to do that? If we multiply it by 10 to the power 3, then it becomes meter. 10 to the power 3 means 1000. Yes, and that is because we know that 1 kilometer is equals to 1000 meter. There are 1000 meters in 1 kilometer. That's why to convert this into meter, you need to multiply it by 10 to the power 3. Now 7.8 is as it is, but here 10 to the power 8 into 10 to the power 3. Now you need to use the laws of indices. Yes, according to law of index, if two terms have same base, okay, if two terms have same base and they are being multiplied, then what can you do? You can add the indices. Okay, this is the law. You might have got it from your mathematics class. Okay, the law of index says that if two terms have same base, then and they are multiplied, then their indices are added. That's why it becomes 10 to the power 8 plus 3. See, bases are same and they are multiplied, so we can add the index 8 plus 3, and that means 7.8 into 10 to the power 11 meter. Okay, I need to find force of attraction or force of gravitation. F equals to what? And from Newton's universal law, we have F equals to capital G m1 into m2 by d square. Okay, G is 6.67 into 10 to the power minus 11. M1 is 1.9 into 10 to the power 27, and M2 is 1.99 into 10 to the power 30 divided by d square means 7.8 into 10 to the power 11 square. Don't forget to put this square sign over here. Now what I can see that there is jumble of different system of numbers. Yes, and what I want to do is I'll separate the numbers in one cluster, separate by bracket, and then I'll separate the numbers having index in another cluster. This is the easiest way to do this question, solve this type of numerical. Now what is 7.8 into 10 to the power 11 whole square? Here also I can use a cluster technique. Yes, and in cluster technique I can take just square of 7.8 and square of 10 to the power 11. Now what is the square of 7.8? 7.8 into 7.8, 8 is a 64, 6, 8 7 are 56, 56 plus 2, 62, 7 8 are 56. Carry over 5, 7 are 49, 49 plus 5, 54. Okay, 2 digits, 60.84. Okay, I get 60.84 into 10 to the power 11 square means 10 to the power 22. Now what can I do? I can use this much as a cluster to find the value and this much as a cluster. Okay, let me use calculator here for a moment. Okay, let me use it. 6.67 into 1.9 into 1.99 and divided by 60.84. Okay, that gives us 0.4145 into 10 to the power. Now this cluster, I'm going to solve it by using the laws of index. Yes, these three terms are being added, so they are being multiplied. That means the indexes are added, minus 11 plus 27 plus 30, whereas this term is being divided, so its index can be subtracted. It keeps like this, so it will be 0.4145 into 10 to the power. What it gives? Minus 11 minus 22 means minus 33, and this to add this to 7, 3 to 5, 57 minus 37 minus 3, 4, 5 minus 3, 2, 24. Okay, 10 to the power 24. Okay, now once again in scientific system this number must be between 1 and 10, but 0.4 is less than 1. That's why you need to shift decimal by one digit back so that it will become 4.145. Now say it is between 1 and 10, it is acceptable. Now since you have shifted decimal backward, what you should do in index? You should do minus 1. Okay, note here. In previous question we did plus 1 because we have to shift decimal forward, but here we need to shift decimal backward. That's why it should be minus 1. So final answer is 4.145 into 10 to the power 23 Newton. This is the answer. Okay, that much for today. I'm going to give you more questions, some more questions for practice. Okay, please check in your messenger group. It will be posted there. Thank you very much.